Okay, so welcome back, and now we're going to talk about what happens, what do we do if part of the curve over the closed interval that we're interested in finding the area of is below the x-axis. Because up until now, what's the condition? That we have a non-negative function over the interval. Continuous and non-negative. Well, what if the second part of that is not necessarily the case? How do we handle that? So here's an example of a function over the interval from 0 to 2. That part of the graph is above the x-axis and the other part of the graph is below the x-axis. So how do we handle this area under the curve when the curve is below the x-axis? Well, let's go back to Riemann sums, right? So if we are going to look at the Riemann sums, what are we going to do? Well, we have the summation as I equals 1 to n of f of x sub I star times delta x, right? So if we look at this here, when it's above the graph, f of x star is positive, right? And delta x is always positive, so we get a positive value. And when f of x star is below the x-axis, it's negative, so the product gives us a negative area. Okay? So what does this lead us to do? Well, it leads us to say, hey, well, the sum of all the areas is going to be the area of the graph above the x-axis minus the area below the x-axis. Okay? And so this is what we call the net area, right? The net signed area. So notice that the signed area can be positive, negative, or 0. If the area above the x-axis is larger, then the net signed area is going to be positive. If the area below the x-axis is larger, then the net signed area is going to be negative. And of course, if they're both the same, then you're going to get a net signed area of 0. So this is called net signed area. Okay? Now that's different than total area, which we'll talk about later or next. Okay? But this is what we have to do. So, and then this is going to be what we're going to do. So the sum, right? So what we have to do is, when we're talking about finding the integral, okay, so we're using the Riemann sum, so when we take the limit, right, as n approaches infinity to find the integral, then it's going to be the area 1 minus area 2, the area above the graph minus the area below the graph, which is going to give us net sign. So you can see from the approximation, if we use Riemann sums from 0 to 1 here, that's going to give us an approximation for A1. And if we use the Riemann sums for 1 to 2 here, then it's going to give us an approximation for A2. So that's where we get the idea. As we take the limit of the Riemann sum, then what we have to do is we have to subtract we have to take A1 and subtract off A2 to get the net signed area. Okay? And then we'll do an example, and then we'll talk about total area. Talk to you soon.